Hello everyone. I hope everyone is good today. So on Monday we just started to do the risk analysis and just quickly went over it. Now we're gonna proceed today with some example with the Excel spreadsheet and how it's applied to get better understanding of what is the risk analysis actually. Let me share the screen with you. Okay. So we said the risk analysis is divided into three parts, like sensitivity analysis, scenario analysis, and the simulation. Sensitivity analysis, it involves examining the effect of the NPV of changes in one input variable at a time. And scenario analysis, it involves examining the NPV effects of the set changes that reflect the scenario, like creating recession, normal, and the boom scenario. And the simulation analysis is about the Monte Carlo analysis that involves the examining the effect on NPV when all uncertain inputs follow their respective probability distribution. So we don't know how the sale will go, and it changes every year and every second. So how the NPV will be then. So these three analyses will help us to determine whether we should accept the project or not. Using these three methodologies to apply on the NPV decision, and using some IRR, we can use the IRR as well. So talking about the sensitivity analysis, as we are given here example, like ABC is analyzing the capital budgeting with expansion project with the following cash flow forecast for 3 years, like unit sales, price, variable cost, fixed cost per unit, and investment in fixed capital, depreciated straight line over the 3 years to book value to zero, and investment net working capital is 15,000. At the end of the termination date, there is salvage value of a certain equipment, which is 10,000. The marginal tax rate is 10%, 40%. The cost of capital is 15%, and the base case of the NPV and IRR are 11, and so on. So we know how to calculate the NPV and IRR using this information. So they give us the calculation. So we don't go for it. Okay, 11,000 and 23.5% respectively. So it seems that it's profitable. We do accept the project in accordance with the result that we get it from the NPV. NPV is positive, which is more than zero. And cost of and the IRR, internal rate of return, is more than cost of capital. That supports our decision as well. So more specifically, talking about the sensitivity analysis, how your NPV will change if you change one certain variable. Okay, you construct your you know what I will do? I will give you this case to solve it yourself, but I want to explain that, for example, you are given certain income statement that you have constructed the cash flow projection that we used to do before, like here. Okay, we construct it. We get the operating cash flow after tax here, we get it, and we get the terminal operating cash flow, and we calculate the NPV. And this is what we did it, okay? Imagine using this table of parameters, like unit price per unit and so on. But this example is not the same with the slide. It's another example, but I'm just trying to explain you what we did it, what has been done so far. So they already calculated NPV, they already calculated the IRR in the slide. So it assumed that you went through this process to get the IRR and NPV, but it's just for 3 years, as you can see, project. So what they were doing, they made down the unit sales by 20%. So they decreased the unit sale. They decreased the unit sale by 20%. If you decrease the unit sales by 20%, okay, like low value, the annual sales, like decreases by 20%, like here. It was 40, now it's 35 unit sales. What will happen to your NPV then? Using only change in units. So other things are equal, but what changes? Only the unit sale changes, okay? Only the unit sales changes. Only the unit sales changes. What will be your then NPV? So you have to try everything one by one. So what is done here actually? So NPV is equal to negative if your unit sale, only the unit sale is down by 20%, which means that if this information is given and the sales, this is decreased by 20%, if it decreased by 20%, assume that it's not 1,500, but it's less by 20%. So 1,500 minus 20%, which is 1,200. So imagine this becomes 1,200. Then what will be your NPV? Your NPV is equal to negative number, and if your unit sale is 1,500, your NPV is positive. It's 11,871, and IRR is more than cost of capital. But your unit sale reduced to by 20%, that made your NPV to go down to minus 458, and IRR became 14.7, which is lower than the cost of capital. So we do not accept this project if the unit sale reduced by 20%. And we put the results. So then, what if the price changes? What if the price changes? The price is 50, and let's make the price fall by 20%. So make the price not 50, but make it 40. What will be then your NPV? Your NPV will be minus 8,000, and IRR will be 8.6. And we proceed. What if your variable cost changes? What if your variable cost falls down to by 20%, the variable cost? Look at the variable cost. It is $20 per unit, but if it falls by 20%, what happens to your NPV? So $20 reduced by 20%, which is $16. If your variable cost becomes 16, then your NPV will be equal to $20, 20,000. And what if your fixed cost changes by 20%, reduce your NPV, as you can see, increases. What if the salvage value changes, and so on? This is the down case, when the case like you're downgrading each variable, and you're trying to see the effect of your NPV, how the NPV is sensitive to changes on each variable. So when who can tell me in here the base case is the normal case where there is no changes, okay? When there is no changes, like everything is its normal condition, like there is no changes, then NPV is 11,000 and IRR is 23%. This is the middle part. But uppercase, which means that what if it increases by 20%? You increase the unit sale, you increase the price, you increase the variable cost and fixed cost and salvage value. And you see what will be the NPV in each case. Okay, you see that what will be the NPV in each case. So from here, we can see that the project NPV and IRR are the most sensitive to changes in price, because when the price drops down, the NPV goes from positive to negative. Here, it was positive and it just goes negative directly, you see? And it goes more to negative in here. And the project is also sensitive to changes in unit sale, because 20% drop in sales will generate a negative NPV as well, but it's not much sensitive as the price. So this is the information that you can get it. And the project appears to be least sensitive to changes in estimate of the salvage value. As you can see that there isn't much change in the salvage value. So anything you want to improve your MPV, improve your project, you should not treat any salvage value. So forget about the salvage, because treating the salvage value will not bring that positive MPV. So what you do in here, you need to find the most sensitive variable. To what MPV is the most sensitive? We say it's the price and unit sales. You can see that the fixed cost and the variable cost doesn't make the MPV negative, so forget about the fixed and the variable cost. Do not improve the fixed and the variable cost, because it's not going to bring you the MPV positive. So what is the thing that you need to work out is unit sales and the price. And the price is the most sensitive variable that you should be cared actually. So we will get one example, which is in Excel here. Okay. Let me just erase this part. Okay. So what we do here, this is table of parameters is given. This is table of parameters are given. Okay. So we are given investment in fixed capital, investment in net working capital, depreciation straight line to 0 for all 3 scenarios, and annual unit. So we created directly the scenarios. Okay, by this is a reduction, this is increase. Okay, and tax rate and required rate of return. So which variable should be taken into consideration? So what we do in here, we put the sales. Sales is unit price times by annual unit sales. This times this. And this will be same for all years. Oops, I have to fix it. Otherwise,
you need to put dollar.
Yeah, I'm just trying to put the dollar here. Okay, now we got the sales. Now variable cost, as we know that the unit variable cost per unit times by the unit sales. Times we don't have in here the fixed costs. Okay, we don't have the fixed cost in here in this example. Just simplicity for simplicity. And depreciation is 50,000 all the years same. Let me dollarize it. Oops, it became 500,000. And now we can calculate earnings before tax, which is this minus this minus this. We can calculate the tax rate, and the tax rate is given here, which is 40%. So 0.40 times the amount. And we get the operating income of the tax. We are bringing back the depreciation. Okay. And okay, this is here. Then, oops, there is some mistake in here. There's a mistake because it's 6 years and I shouldn't have anything in year 0. I shouldn't have anything in year 0. Let me just erase this part and bring this part to here. Okay. Now my cash flows, operating cash flow after the tax is here. So this plus this. And my total non-operating cash flow is the salvage value, which is 60 minus 60 times the tax rate and plus change in net working capital, which is this 50,000, which is 86. So my salvage value is this. And what happens here? So we can see that our NPV, so this plus this, our NPV changes, okay? So this is, we created the base case, okay? This is base case. If nothing changes, this is the base value, okay? And NPV will be this. And in the base case, I just put all the NPV same. In the NPV nothing changes, okay? We assume there is no changes in the variables, okay? Nothing changes. Now, what I will do, I will change the unit price. I will change the unit price. I will change the unit price in order to fill these ranges. So I will change only the unit price. So my unit price is not $5 anymore. Now it's 4.5. It's 4.5. Okay. So that means changing the unit price to 4.5, my sales and the variable cost will change in numbers. So my sales will be not 5, but it will be 4.5. And my variable cost will change. Oh, sorry, my variable cost doesn't change. Only the unit price changes. Okay. So once my unit price changed, I changed my sales, and that changed my NPV. It reduced from 121 to 71. So as you can see here. So I put this number here directly. Now, my turn to change the annual unit sales. I'm changing the annual unit sales. My annual unit sales is not 40,000, but it's 35,000. Everything remaining in the base case, but only the annual unit sales changing. Okay, we put everything back, but annual unit sale changes. And of course, my variable cost will be changed because the annual unit sales is not 40, but it's 35. So you can see my NPV here, new NPV. So I put this NPV here when the annual unit sales changes. Then I go for changing variable cost per unit. Now everything will be kept same. Everything will be kept same. Okay. The sales will not change. The sales fixed. What is going to change? The variable cost per unit will be not 1.5, but will be 1.40. 40,000 annual unit sales. and only the variable cost per unit will change. So let me update it. Okay, now you can see that NPV changed. So new NPV, I just put this NPV to the corresponding row of the variable cost per unit. So as you can see. Then I change expected salvage value. I change the expected salvage value. My expected salvage value will not be 60, but will be 30,000. Okay. So what I do here, I go to, I put everything into the same order. Okay. I put this into this back to the base case. I'm putting back to the base case everything. Yes, do you have any questions? Okay, I'm putting back everything to this back to the base case order. Let me check my NPV is same. Yeah, now in the base NPV. Now, what is changing? Only the expected salvage value. I'm changing the terminal non-operating cash flow part. So my expected salvage value is not anymore 60,000, but it's 30,000. Only the expected salvage value changing, guys. Look, what happens to your NPV? Reduced to this amount, but still positive. And we proceed further, and we put this NPV to here. Then we proceed with the tax rate. What if your tax rate changes? But to do that, you have to put everything back. You put everything back so that your NPV is the base. Okay. Now you will change only the tax rate. Tax rate will be 38%, not 40%. Oops, I have to fix this. 38. Okay, and my terminal operating cash flow will change with the tax rate. My tax rate is 38%. Now let's see what happened to your NPV. My NPV increased once the tax reduced. Okay. And the last part, what I'm treating is the required rate of return. Required rate of return. I'm treating required rate of return. So, but in order to do that, I have to return everything back. Should bring the tax rate back. Okay. And of course, I have to change this tax rate as well. So everything in the same order now. The base NPV. Now I will change only the rate. It's not 12, but it's 10%. Now my NPV is here. So this is the, I created low base case. So you will do the same thing for the high case. Let me do it. Let me do it. So for high case, I bring back everything. I bring back to the base level. Now I will change the unit price, but I will change with increase. Okay, unit price will not be 5, it will be 5.5. But what is the best thing that I can do in here so that I don't waste the time? I can make it like this. Okay, make it like this. So this will help me automatically to change everything. Okay, once I change here and make here like this. Okay, that's great. Now I change the formulation. Okay, now I will change the unit price. Once the unit price changes, the annual unit sales the sales will change. So my unit price is not anymore 5, it's now 5.5. So as you can see, automatically all the sales changed. What happened to my MPV? It became 170. It reached its maximum point, its maximum level, okay, the highest level, 170 million or 170,000. What if I change the unit sales? What if I change the unit sales, put it back everything, but I changed only the unit sales? My unit sales is not 40, but 45,000. What will happen to my MPV if I change only the unit sales? And I have to change the variable cost part as well. Now my MPV 164, okay? So I'll have to move to variable cost per unit, but let me put it back everything. Like nothing changed. Nothing changed. Okay. Now, so what we do here, we will change the variable cost per unit. The variable cost per unit will not be anymore 1.5, will be 1.6. Keeping the other things same. My MPV becomes, oh, yeah, here we go. So if the variable cost per unit changes, increases, my MPV will be still positive. Great. Then I move further. Oops, sorry. So I bring back. Okay. Now I would like to move to expected salvage value. Change the expected salvage value. Bring the expected salvage value here. My MPV increased to 127. What if the tax rate changes, but we need to bring everything back? What if the tax rate changes? We will change the tax rate, make it 42%, so increase the tax rate. So as you can see, your MPV reduced from the base level. And what if the required rate of return changes, but bringing the tax rate back? We need to bring the tax rate back. Oops, wait. If we do this, our MPV 113,756, but it doesn't match. What is the problem? Who can tell me? Why it doesn't match? Why it's not matched with this? It should be matched. I changed the tax rate. So what is the problem?
Operating cash flow, maybe.
Sorry? Operating cash flow?
Yeah.
First of all, when we change the tax rate, we have to think where we use the tax, in which cases. So those parts you have to think of it.
Also, non-operation cash flow
Yes.
changed.
Yes, terminal non-operating cash flow, salvage value should be changed.
I said it like that.
Instead for 40, it should be 42.
Okay, we have to change it to 42 here as well. Okay, now it's matched. or still not matched? Wait a second. Just a second, there's one miss, it's not matched. 148. Let me check it. 42%, 60,000, and plus this. Okay.
There are only decimals are not the same. Yeah.
Only the decimals is not, but they should be same. They should be same. They should be same. Just a second. Why it's not the same? Maybe I put it here wrongly, but let me check that because this example comes from the book. Let me check just direct from the book. Okay. Okay. 113, 148. Okay, that means I put it wrongly here. Okay. It should be here with the decimal numbers, 0.15. But it should be exactly from here. Okay, now it's this was my mistake, error typing. So I just got directly from the book. In the book, they do not disclose all the decimal numbers. Okay. Now we got then the last part. What we do here is the required rate of return. Thank you for your participation, guys. Thank you. And we return everything back. The tax rate should be go back. Should begin back. Okay. Now. Okay. The last part where we change only the tax rate. We change the tax rate. Or sorry, changing the discount rate, and our discount rate becomes this. So we calculated it in upper and lower cases with the sensitivity analysis. We now can see that we take the ranges, like the difference between high and the low, and we select the highest. So we can see that unit price is the most sensitive part. So changing in the unit price will affect tremendously the NPV. So whenever you want to improve your NPV, you should pay attention to the unit price. And the next most sensitive one is called annual unit sales. Annual unit sales. And what is the least sensitive? It is expected salvage value, as the example given in the slides. So as you can see here, so the most part is what change, but in all cases, your NPV is positive. In all cases, your NPV is positive. Okay, let me save this example. Risk analysis. Sensitivity and scenario. Okay, this was a sensitivity analysis. Same thing they did in here. Exactly, performance was here. Okay, now we're moving to the scenario analysis. We move to the scenario analysis. So the key difference between the scenario analysis and sensitivity analysis is that the analysis will let you for changes in multiple input variables all at once. But what we do in sensitivity, we change only one variable, keeping all other variables unchanged. So this is how we work. In scenario analysis, we study the different possible scenarios like worst case, best case, and the base case. We create different cases. Imagine we have base case is this one. Okay, let me just, actually it's calculated here, but let me just make it from the beginning. Okay, imagine this is the base case. This is the base case. Like normal case, nothing changes. And the rate is the same. Rate is the same. So the rate is not 12, it's 14. Sorry, 12 is not 14%. So this is the base case we have the NPV equal to. So what we do here, what if all variables change in one time? Okay, we change everything in one time. So that means my unit price and annual unit will change it from 5 to 4.5, from 40 to 35 respectively. My variable cost, but let me perform it in the separate sheet, okay? Let me perform it in separate sheet. Let me perform it in separate worksheet. Okay, I'll copy it. I'll copy it here. Paste it. Okay. Now this will be worst case. Worst case. So that means I'm gonna deal with the lower bound, with the lower values. So I will move just to the right, taking the lower bound. If my unit price goes down and annual unit sales goes down as well. As you can see, everything changed. My variable cost, the problem in here, when you create the worst scenario, you should make everything worse, okay? Like you should not, in here, the lower bound, what you do here, you reduce the numbers, but for the variable cost and for the cost, you should not reduce it, you should increase it to make it the worst scenario, the worst possible scenario, okay? So annual unit sales, so what we do here, you have annual unit sales with a lower case, okay? But you will have the variable cost highest one. This is the key difference. Please get it into your mind because you're trying to create the worst scenario. Depreciation doesn't change, okay? We basically, what we do, we get, in the worst scenario, we get lowest profit and highest cost. So depreciation doesn't change. What will be changed is the tax rate. And cost of capital will be the worst. So the idea is that less profit and more cost should be incurred during the worst scenario. And of course, in here, this, and the tax is 42%.
Sorry, Professor, you are doing in wrong table.
Yes, that's very true. I'm doing it wrongly because, okay, thank you so much for, okay, I didn't change anything here. Yes, I changed it, you see. Now the tax, what about this one? Okay, this okay. 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 So this is what I change it. Okay, great. My tax rate should be highest. And my salvage value. At the beginning. So this is salvage value minus times the tax rate and plus the change in net working capital. Okay. And my investment cost is this. Okay. So we change all the variables at once. Depreciation is fixed, it doesn't change in all cases. Tax change and variable cost change, sales change, and terminal and operating cash flow has changed. Okay, this was the worst case. So as you can see in the worst case, even the NPV, but why my worst case is higher my NPV? That makes the things, of course. That's why it makes my rate is 14%. Okay. Minus around 40, around 50, and this is the range we select. And my discount rate is this. Okay. So in worst scenario, my NPV is negative. Now I'll create the best scenario. In the best scenario, we'll select the best values. So in here, which means that we'll increase the number of the annual sales and the price per unit should be increased. And variable cost should be the lowest. Variable cost should be the lowest. Depreciation, same. EBIT change, the tax rate should be the lowest in the best scenario. So we are coming to salvage value. So highest minus this times with the lowest tax rate and plus the change in net working capital. Okay. And my investment cost. Okay. And my rate is not 14, but it's 10%, the lowest discount rate. Okay, this is my best scenario. Okay, I didn't miss it. Okay, this is my best scenario. This is my worst scenario. This is my best scenario. Okay. So this is the main difference between scenario analysis and sensitivity analysis. This is the main difference between that. So, however, it will in here you cannot make any decision yet, but you need to do Monte Carlo analysis in order to come up with a certain decision whether you should accept or reject the project, whether it's expansion or replacement. Any questions? Okay. I will upload it to the Moodle. It will work out, but if you don't have any questions, let me take attendance. Because it's obligatory nowadays. Take attendance now. Okay. Sanjar, just raise your voice if you're here. Islam,
I'm here.
Aidai,
I'm here.
Yasmin,
I'm here.
Jean, Aman geldi.
You're here.
Niyaz,
I'm here.
Tomiris,
I'm here.
Yerzat,
Here.
Gablugani,
I'm here, Professor. I'm here.
Okay, that's good. That's really good. Raushan, Binura, okay, that seems that the Binura, she's not here as well. Aidana,
I'm here.
Begzat, okay. Zirui,
Here. I'm here.
okay. Sultan, not here. Daujan,
I'm here.
Eldar,
I'm here.
Aydos, Gani,
I'm here, Professor.
somebody wrote. Okay. Aydos here. Artur,
Здесь.
Gaziz,
Here.
Baglan,
Here.
Zarina,
I'm here.
Abdurrahim,
Here.
Rayhan,
Here.
Alibek,
Here.
Daniar,
I'm here.
Sanjana,
Here.
Dalirkhan,
Here.
Baglan, Kleshov,
Here.
Milana,
I'm here.
Arnur,
Here.
Ilyatsoy,
Here.
Daniel,
I'm here.
Vladislav,
I'm here.
Diana,
Here.
Clementi,
I'm here.
Janelle,
I'm here.
Camila, Adilhan.
Yeah, I'm here, Professor.
Okay, that's great. Okay, if you don't have any question, I will let you go earlier today by 15 minutes. I'm done for today. If you have any question, please feel free to ask. If not, you can leave the conference. Thank you so much. See you on next week.
Thank you for the class.
Thank you, bye.
Thank you.
Thank you for the
Goodbye.
lecture.
Bye.
Goodbye.
See you guys.
For the lecture.
Thank you. Goodbye.
Have a nice day.
Bye. You too, guys. You too.
Thank you.
Bye. Good luck.
Professor, can I ask you one question?
Yeah, sure, sure.
So we will have quiz